Are you guys ready for Gauss's law? I didn't ask Caroni. Caroni, how'd I do on that last one? You think I did a good job on that first page?
Should I really answer this?
Yes, you should. All right, is this going to be a good one when I actually put Gauss's law out there for the class to listen to? What do you think, Caroni?
No doubt.
Oh, it's going to be a good day. It's a good Sunday. So let's define this thing called. Pick our colors. Let's go with a nice. See, oh, look at this. We have a brown. There we go. We will pick a nice brown color by popular demand. I like this as blue. I'm gonna pick that nice crimson blue. That sounds great. Crimson blue. There we go. The crayon, which people don't like, I will use a nice reddish. And for I definitely use the purple there. All right, check colors here. Make that a little smaller. There we go. We got the blue, right? Blue, come on. That's a nice size, and that's a nice size. All right, here we go. Dun, dun, dun. What is Gauss's law? Okay. Just the hardest thing for most people. Ooh, look at this. We got the brown going. Okay, so let's start with Gauss's. Now, if this were an English class, do you put an apostrophe S? Or can you just put apostrophe? Listen, if it ends in S, you could just put an apostrophe and just call it Gauss' law. But of course, people don't like that, so they'd rather see Gauss's law. So we'll put Gauss's law. Okay, Gauss's law essentially defines flux from a point charge several ways. From a point charge, mathematically, I like that one. That's the problem with Gauss's law. It's mathematical. So Gauss defines flux coming from a point charge mathematically several ways. And that's what confuses people. Kind of like Fat Mav had three equal signs. It was J equals F delta T, which equals delta P, which equals M delta V. I think that's 1, 2, 3 equal signs. We're going to have the same thing here. So we start off with flux. Let's do this in the blue. That nice blue color. So we start off with flux electric. So I'll call it flux electric. So flux, remember that's flux. Right, that's your flux. That's your lines. That's just lines. Now flux equals, now here's the first setup. Now you remember how we said it was E times A? Well, you can integrate that, all right? Because it's going to be E times A. So E times A is going to be an integral. But we're going to have a funny little thing here. Now, you notice how we put a little circle in phi? We put a circle here, too. I'll get to that in a second. That's a special, I'll get to it right now. It's a special kind of integral called a surface. No, let's spell this correctly. This is what we call a surface integral. If you ask Prentice about surface integrals, he will tell you it's very hard to derive surface integrals. But we are going to do it the easy way. Don't worry about it. That's your surface integral. Okay? That's your surface integral. Right? Now, that is the integral of E dA. So it's very similar to what we did before. It's E times A. All right? E is the electric field. Right? That's the field at a defined, and this is the hard part, it's something new, the defined Gaussian, wish I had echo, Gaussian surface. Come on, let's do it right. Define Gaussian surface. All right, put that in quotes for now because I haven't taught it yet. All right. And that's an and that's going to be an infinitesimally small, infinitesimally, is that right? Is it oh, come on, learn how to spell, dude. Infinitesimally small area. So what we do is we take our Gaussian surface, divide into little tiny areas of dA size, and then we look at the electric field in each of those little tiny pieces, and then we sum them all up. That's what your integration is. Okay? Now, wait, here's that other equal sign we were talking about. All right, it equals this. And this is probably the most important part that people forget, because when you're solving a problem, when they ask for flux, people think, oh, I need EDA. No, sometimes you just need this last part, which is what we call Q enc. Now, what's Q enc? Q enc equals Q enclosed. All right, Q enclosed over, remember that? Epsilon naught. So there's your Q enclosed. And of course, that's the permittivity of free space, which is 8.85 times 10 to the minus 12th. You remember that? You do remember that, right?